In solutions chapter, solutions आपने तो नहीं किया ना start हमारे साथ, फातिमा मुनीर, ना ठीक है. In solution chapter there is the first topic is all about concentration terms. Okay, so this is something that we have already covered. Concentration terms we have already covered. Okay. Acha. So Fatima Munir, you have been absent for so long, so I will take one class on Friday, है ना, because बाकी दोनों में आपके कुछ ना कुछ class होंगे. Friday will be holiday for you, so I will take one class on Friday. Is that all right?
Yes, sir, it's fine.
You where are you? You are in Kingdom, na? Saudi Arabia, right? Fatima Munir?
I'm in Kuwait.
Kuwait. So you follow the time for Kingdom? या आपको कुछ अलग है time?
Yeah, नहीं, same है.
Same है ना? You share the time with KSA. Okay. So 4 p.m. KSA will be fine on Friday. The same timing. आज की तरह.
Yes, sir.
Okay, fine. Okay, I have taken yes, sir. फातिमा मुनीर से. It has been recorded. बाद में अगर आपने मना किया ना तो फिर recording देखने मिलेगा आपको. ठीक है? So after solution we have another term which is solubility. So solubility is something that we are going to study today, है ना? And those students who remember what was done in the last class, there is a part of normality. Okay, so normality, what I'm going to do, normality, I'm going to teach you guys, like at the end, towards the end of colligative properties, there we have a similar thing going on, which is a quantum factor. So we will study normality at the end. Okay, colligative properties. Today we'll be starting with solubility. Solubility. So all of you, please write the heading. Solubility.
Sir, you told you will explain what is gram equivalent.
हाँ, तो normality तो उसी में है ना.
But you already started normality.
नहीं start क्या मतलब वो बस हमने फॉर्मूला लिखा है ना.
The formula, yeah.
फॉर्मूला लिखा है ना, तो इसको हम like because it is a concentration ना related to concentration term, I will explain this on like when we start colligative properties ना at the end, abnormal molar mass, abnormal molecular weight, उसमें I will explain normality. ठीक है, इसकी जरूरत नहीं है अभी यहाँ पे, that is why I am just leaving it off here. Okay, got it, Fatima?
Yeah.
Okay. And also एक और उसका reason ये है कि like in CBSE examinations you will not be asked about normality. ठीक है, तो NCERT में नहीं है. 12th standard NCERT don't have normality there, so you will not be asked about it. And जो NEET और JEE है उसमें sometimes they use the word of normal here and there, so you have to know that too also. ठीक है, so solubility. Okay, I have given you salt, ample amount of salt and ample amount of sugar. ठीक है, both you have 1 kg, and then I have given you a glass of water, and both the glasses of water is 100 ml. Okay, it is 100 ml. Now those who have been to kitchen and they have mixed a few things, you will tell me which will be getting dissolved more easily, salt or sugar. If I add salt into water, that will be getting dissolved easily, or sugar will be getting dissolved easily. Tell me. Adriel, बताइए. What do you think? Which substance will get dissolved easily?
Sugar.
Yes, Fatima Munir, what did you say?
Sugar. I think it's sugar.
Sugar. Okay. Adriel, what do you think?
I think it's salt.
Salt. Okay. Alida, what do you think?
Is that sugar?
Sugar. Okay. Okay. Mohammed Umar, hello. How are you? Wait a second, guys. Yes, Umar, am I audible?
Yes, sir, you're audible.
Okay, fine. So I am asking a question. Out of sugar and salt, which is more dissolved, which is more soluble, or which can be dissolved easily? Which can be dissolved easily? Which can be dissolved easily? Tell me. Mohammed Umar, आपका क्या ख्याल है? Which can be dissolved easily?
Sir, can you repeat the question once again?
Out of salt and sugar, which will be dissolved easily? Okay, Fatima got your answer. Huh?
Sir,
Umar?
sugar.
Sugar will be dissolved easily. Okay. Those who are voting for sugar, please raise your hand. Raise your hand even if you have answered me. I think Adriel ने कहा था sugar. मोहम्मद उमर, raise your hand. है ना? जिन लोगों ने भी क्या कहा है? Salt. अच्छा, you are salt party. डांडी मार्च करेंगे हम लोग. फातिमा मुनीर salt? नहीं. हुजैफा salt? Okay, Sara salt ना? Sara, am I audible?
Yes, sir.
Okay, Josefa salt, Sara salt. Okay, fine. Achha. Those who have raised their hand, एक बार बताइए आप लोग, which requires stirring, salt या sugar mix करने के लिए पानी में? Which substance requires stirring, salt या sugar? Both. Fatima Ansari, can I have you please?
Yes, sir.
Fatima Ansari, no, this is not right now. Both needs stirring.
Yeah.
How many of you agree with Fatima that salt also needs stirring? If you will not stir the salt, then it dissolves as you are putting the salt in. No. Okay, so all of you agree. Casey, you also agree that salt also needs stirring.
No, sir. Was I supposed to? Okay, wait. Let me.
Raise your, now everyone raise the hand if you agree with Fatima Ansari that salt needs stirring. Okay. Okay. Muhammad Umar, you think salt needs stirring?
So I don't think so.
No.
No.
Okay. So obviously now you tell me there is a substance that requires stirring in order to get dissolved in water, and there is a thing which does not require stirring to get dissolved in water. Then obviously which is more soluble? Salt, right? Yes or no? Yes or no? Tell me, guys. Fatima Ansari, you agree? Are you convinced that salt will be more soluble? Yeah, Bibini.
Yes, sir.
Yes, no. So if you have doubts and all, then you can ask your mother.
But the molecules of sugar are bigger than the molecules of salt, right?
Okay, agreed. So
they must, the molecules of sugar must dissolve faster than salt due to that reason.
Due to what reason?
Due to the
Bigger
reason
in
that,
size?
yeah, bigger in size. The molecules
Why?
are bigger.
Why is bigger in size a criteria? Why will be bigger in size a criteria?
Because the water molecules would surround a single particle, and this would lead to faster.
That you are correct about that. अब ये बताइए, छोटी चीज को सराउंड करना आसान है, बड़ी चीज को सराउंड करना आसान है?
छोटी चीज को.
Sorry, what?
Sorry, I'm sorry. बड़ी चीज को.
बड़ी चीज को सराउंड करना?
Yes, sir.
आसान है?
इन दोनों को करना आसान है शायद.
दोनों. Come on. आप अपने हिसाब से सोचिए, आपको ज्यादा दोस्त कहाँ लगेंगे किसी को घेरने के लिए? छोटे से बच्चे को या फिर एक हल्क जैसे आदमी को?
हल्क जैसे आदमी को.
वो आसानी से घिर जाएगा?
नहीं, उसमें ज्यादा लोग रहेंगे उसको घेरने के लिए.
ज्यादा लोग लगेंगे ना, तो which is more easy now?
जो छोटा वाला आदमी है.
Still, salt is more soluble. Correct? है ना?
Yes, sir.
Okay, fine. So this is what we are going to talk about in solubility. Solubility means, so solubility means that the maximum amount of a substance that can be dissolved in a fixed amount of, the maximum amount of solute, so yeah, the maximum amount of solute that can be dissolved in a fixed amount of solvent. Okay, so this is the first thing that we will write about solubility. So it is the capacity of getting dissolved, and we are talking about what? We are talking about the solutes. Ye yaad rakhiyega. We are talking about solutes here. So what we will write here is the definition of solubility. Is the definition of solubility. So what is solubility? Solubility is the maximum amount of substance. Okay, whose solution chapter has just started in this batch. No, concentration terms is done. आप बहुत late हो, Umar. I mean, even after having that 1 hour lecture with you, a small session with you, उसके बाद भी आपने बहुत सारी classes join नहीं किया. I don't know why, है ना? So you are too late. ठीक है? लेकिन we have an extra class on Friday. We will take an extra class on Friday. उसके बाद हम लोग कुछ करेंगे. So solubility is what? Umar, can you please? Not all, no. For all of them who have missed the concentration term. Solubility of a substance, please write. Don't send chats now, huh? Speak if you can. Solubility of a substance. अभी कहा don't send chats, अभी फिर chat भेजा. Okay sir का भेजा क्या? हाँ. Solubility of a substance is its maximum amount that can be dissolved in a fixed amount of solvent at a given temperature. Okay, so please write this down. इसको लिखने की जरूरत नहीं है, ठीक है? ये जो हमने explain किया ना, इसको लिखने की जरूरत नहीं है. Solubility heading डालिए, then write the next point. Solubility of a substance is its maximum amount that can be dissolved in a fixed amount of solvent at a given temperature. Now, for example, when we have NaCl, please listen here, don't write now. NaCl, and when I add water to NaCl or I add NaCl to water, what happens? I see that Na get dissociated into Na plus and Cl negative. So Na plus is losing its identity, right? NaCl in the solid state, it is combined, it is together. But in aqueous state, in aqueous state, what happened? The Na plus and Cl negative, they dissociate with each other and it loses its identity. And as Muhammad Umar was saying, so Na plus, how it is solvated? You have water molecules whose oxygen end is directed towards sodium like this. Okay, and they surround the sodium atom. And when they are surrounding the sodium atom, that means sodium ion here. The sodium ion is away from chlorine ion. That is why these are isolated. Now, why is this happening? Because oxygen negative has delta negative charge and H plus have delta positive. So all the delta negative from oxygen, it interacts with, there will be a attractive interaction between oxygen and sodium ion. So that is why it is surrounded like this. The chlorine ion is also surrounded, but it is surrounded through the hydrogen end of water. So this process here, it is known as what? This process here, it is known as dissolution. Now you all know that the molecules inside a liquid state, they are always moving, right? They're always moving. So there is a chance that sodium positive and Cl negative, for a very instantaneous moment, for a very little moment, what will happen? They will be coming together and they will be not surrounded for water for a while and they will combine together. So both of these chances are there. So when they will combine together, what is going to happen? they're going to form NaCl, that is again the salt. Now this process is known as crystallization. Crystallization. Now both the things are happening all the time. Both the things are happening all the time. That means the equilibrium that we are seeing here, it is dynamic in nature. But if you have very small NaCl, then the rate of dissolution is very high because there is less sodium atoms and less chlorine ions, and it is getting surrounded by water molecules. The water molecules are predominant here in dilute solution. So you see no NaCl. NaCl आपको नहीं दिखेगा, the solid NaCl. But as we keep on adding the salt, that is NaCl, more and more, what happens? The amount of Na plus and so chlorine negative is getting larger, and surrounding them is getting difficult for water. So you may see some crystallization also happening for some time. Okay? You will also see crystallization happening if you have the concentration or the solution is having too much of NaCl, right? Too much of NaCl, then you can see that you are not dissolving anymore. So when you are not dissolving anymore, that means what is happening? There is always a constant crystallization that is happening with each and every step of dissolution. Okay? So please write this down, and then we can write a few things about dissolution and about crystallization. So whenever we add, so please write with me. Please write with me here. I've explained what is dissolution. I'm just writing the same thing here. Okay. So when a solute is added, when a solute is added in a solvent, some of it dissolves and its concentration increases in the solution. This is known as dissolution. Okay, this is what? This is known as dissolution. Now the next term, that is crystallization. So when does crystallization happen? Crystallization will happen only if the solute particles will be colliding with each other, right? So some solute particles may also collide with each other. And so when they are colliding with each other, what they are forming? They are forming NaCl, that is the NaCl, that is a solid. Okay. So as soon as it is forming a solid NaCl, they are getting separated from the solution. They are no more in the aqueous phase. They're out of the aqueous phase. Even though you will see that they are inside the water, but they are not dissolved. And if they are not dissolved, that means they are separate from the solution and get separated. And gets separated from the solution. This is known as crystallization. Okay, this is known as crystallization. So please write these 2 points. So add one more point. The equilibrium between dissolution and crystallization is dynamic in nature. So please write this down. Let me know when you're done. Raise your hand when you're done, okay? All of you, please raise your hand when you are done. Waiting for Fatima, Munir, and Huzaifa, and Muhammad Umar. Just waiting for Umar now. Okay, thank you very much. Now, there are two more terms, and whose definition and whose meaning I hope you already know. It is saturated solution and unsaturated solution, right? All of you know what is the meaning of saturated solution? Yes or no? Tell me. Yes, saturated solution, guys. Yes or no? Adriel, Alida, Huzaifa, Muhammad Umar, Fatima, Casey, and Sarah, guys, tell me.
A solution where no more solute can be dissolved.
Yeah, correct. Yeah. So I hope this is the definition that you already know. That please write with me, okay? Please write with me a solution in which no more solute no, this is a very wrong word. Can be added, nahi, can be dissolved. Add to kar sakte hain, dissolve nahi hoga lekin. No more solute can be dissolved. Also at a given temperature. Another word that is unsaturated solution. So a solution in which more solute can be dissolved at a given temperature. Everyone is clear till here, right? Don't raise your hand, just tell me. All of you are done now. Is there anyone who is still writing? Is there anyone who is still writing? No. Okay, fine. Now, listen, all of you. We have learned about solubility. And what is the definition of solubility? And what is the processes that is happening in solubility? Whenever something is getting dissolved, there is also dissolution and crystallization happening. And at the same time, the rate of dissolution and rate of crystallization tells you whether you will see some solid or you will not see any solid. Then both of these processes, they are in dynamic equilibrium. Now let us look at the factors affecting solubility. Factors affecting solubility. So essentially, we will be learning about three types of solution. Please listen very carefully. Our solvent is always going to be a liquid. We'll study what are the different factors that affect if I add a solid to liquid, if I add gas to liquid, and if I add a liquid to liquid. Okay? So these are the three solute particles that we will be studying about, but the solvent is going to be the same, that is liquid. So first of all, we'll start with solid and liquid. Factors affecting solid and liquid. So please write with me the heading. Please write with me the heading. Factors affecting solubility of solids in liquid. Solids in liquid. Okay. Now, the number one reason, that is also in terms of importance. Number one reason will be the nature of solute and the nature of solvent. Like we saw that if I am using salt inside water, it is more soluble. But if I use sugar inside water, then it is less soluble than salt, right? So what kind of, or what is the substance that you're using as solute and solvent precisely, that is also going to determine the solubility. So first thing is the nature of solute, that is solid, and solvent, that is liquid. Okay. Now, next is pressure. What will be the effect of pressure? Now, if I look at pressure here, now if I'm looking at pressure and I want to ask, how is the pressure affecting solubility of solid, right? Solubility of solid. Now, the bigger question is, will pressure have any effect on the solid itself? If the solid, it is not getting affected by pressure, then a property of solid will obviously not get affected by solubility. Yes or no, please tell me. And if I'm increasing the pressure, there is no change in solid because it is incompressible. That is why there will be no change in the property of solid, that is the solubility of itself, right? So next thing about pressure is that it does not have, is this clear with everyone? Yes or no, please tell me. It does not have, हम सबको बाहर कर देंगे अगर जवाब नहीं आया आप लोग का. If I am asking something, is this clear? Yes or no? You have to tell it ना. फिर हम पूछे ही नहीं फिर निकलते जाए. Last time also I have told you guys on Wednesday, you guys don't speak, huh? Yes, Adriel, Alida, Fatima, Ansari, Huzaifa, Casey, Muhammad Umar, Sara, what happened? You understood why the pressure is not affecting the solubility of solid, yes or no?
No, sir.
What about others? What about others? Adriel, Alida, speak. I'm not looking at chats. Speak.
Yes, sir, it does.
Sir,
Understood. What about others? Fatima
Yes,
Munir,
sir.
Fatima Ansari.
So I didn't
Okay.
understand.
Fatima Munir did not understand. Who else did not understand? Tell me.
I
Sami,
didn't get it, sir.
So could you explain them?
Casey. ठीक है हाँ. इसीलिए बोलते जवाब दीजिए. Will pressure have any effect on solid? Will pressure have any effect on solid?
No.
Yes or no? Tell me. Why?
because it is incompressible.
Because it is incompressible. Now, if the substance itself is not changing, then the property will also not change. Yes or no? Because
Yes, sir.
if the pressure, if the pressure can have any effect on the solid itself, then only the properties of solids can change. Now pressure is not having any effect on solids because it is incompressible. Then evidently the property of solid will also not change. Is this clear? Casey, Fatima, Munir,
Yes, sir.
Yes, sir.
everyone? Okay. तो इसीलिए I am saying आप लोग जवाब दिया कीजिए. ठीक है? चलिए. Moving on. So it does not affect. It does not have any effect on the solubility. On the solubility as what? Solubility of of solid and liquid. As solids are incompressible. Solids are incompressible. Right? So we have looked at two of the factors. The third factor is temperature. Temperature. Now, listen about temperature. Don't write anything. Listen about temperature. Now, whenever we have temperature as a case, whenever we have a temperature as a case, then the process of dissolution, it can be of two types. One case will be A plus B, AB. There is AB. It will require some heat in order to get dissolved as A plus and B negative. So this is the case where the process is endothermic. And if it is endothermic, the enthalpy of dissolution will be what? It will be greater than 0, that it will be positive. Enthalpy will be positive. And another case can be there when you have AB, and when you dissolve it, you get some heat. So heat is liberated by this process, A and B negative plus heat. Okay, so this is exothermic, and the delta H is going to be negative, less than 0, that is negative. So all of you know endothermic, exothermic, right? Endothermic, in which heat is required, and exothermic is where heat is released by the system or released in the process. Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. Now, if I'm increasing the temperature in endothermic case, if I'm increasing the temperature, I'm increasing the amount of heat. Is a kind of reactant, yes or no? It is not a material requirement, but it is a requirement, or it is a reactant. If heat is not present, it will not get dissolved. That means it is a reactant, right? Energy ke terms mein, but it is a reactant, yes or no? Please tell me. Can you understand heat as a requirement, as a reactant?
Yes, sir.
Yes,
Okay.
sir.
So if I'm increasing the temperature, I'm increasing the amount of reactant, and that is why what will happen? More and more products will be formed. The equilibrium, it will shift towards what? The equilibrium will shift in the forward direction. Is this clear? Yes or no? Please tell me. In
Yes,
this
sir.
process,
So can you repeat that again?
नहीं, equilibrium आपको पढ़ाया हमने ना मोहम्मद उमर, yes or no?
Yes, sir.
है ना? तो हम तो if I will show you this exact thing कि temperature increase करने से endothermic process में क्या होता है.
I mean, I
Anna, so
didn't
see-
exactly got it what you said.
I said that when I'm increasing the temperature, I'm increasing heat, right?
Yes, yes.
Yes or no? Can you see it is a reactant here?
Yes.
So if I'm increasing the amount of reactant, the product ज़्यादा बनेंगे ना?
Yes, sir.
Got it? Okay. So temperature increase करने से what is happening? Solubility is also increasing.
Sorry.
Yeah, because it is getting more and more dissociated in the forward direction. So what happens? Solubility increases. Okay, in endothermic, if I increase the temperature. Now, in exothermic, अगर हम increase करेंगे temperature, then what you see? The heat content is in the product. So what I am doing, I'm increasing the amount of product. Now, please remember, if I increase the amount of product, then what will happen? The backward reaction will be favored, right? Because we are getting more and more products here, so backward reaction will be favored, and what will happen? The solubility will decrease. The solubility will decrease. Is that clear? Yes or no? Please tell me. Are both things clear? So you'll write here.
Yes, sir.
Yes,
You'll
sir.
write here. In exothermic,
Yes, sir.
where the delta H is what? Delta H is less than 0. That means it is negative. And what is going to happen? Increase in temperature. Leads to decrease in solubility. Decrease in solubility. Next is in endothermic. And the process is endothermic. Delta H is greater than 0. That means it is positive. It requires heat, and increase in temperature leads to increase in solubility. Increase in solubility. Can you please write this down? Raise your hand when you are done. After this, we will look at the solubility of gas and liquid. Please raise your hand when you are done. Sarah. Waiting for Sarah and Muhammad Umar. Okay, those who are done, just write the heading: factors affecting solubility of gas and liquid. Factors affecting solubility of gas in liquid. Factors affecting solubility of gas in liquid. मोहम्मद उमर हो गया आपका?
Yes, sir.
Okay, fine. We'll start. The first factor will be again the same thing, that is the nature of solute and solvent. That means the nature of liquid and gas and liquid, right? Nature of gas in liquid. Okay, and the next we will be looking at temperature. Now listen for temperature, don't write anything. Temperature. Tell me what is going to happen if I have a container like this. This container has some water and there are some gas particles that I have dissolved in it. Dissolved some gas particles here and I am heating it. And I am heating it. So tell me what is going to happen. The gas will escape out of the solution या फिर वो ज़्यादा ही mix हो जाएगा. Tell me if I heat a solution that is containing gas particles, what is going to happen if I heat it? The gas particles will escape. Yes or no? Tell me.
Yes,
Yes, sir.
Right? The gas particles will. नहीं close नहीं कर रहे हैं obviously. Okay. So it is open and what will happen? All of these will be escaping out. Right? So बताइए solubility क्या हो रही है? Solubility is increasing or decreasing?
So is it decreasing?
Yeah, solubility, that means it is inversely proportional to temperature in the case of gas and liquid, right? In the case of gas and liquid. Now,
Because of the reason that it is trying to escape, right?
because it will escape, है ना?
Yeah.
Because it will escape. Okay. Now, solubility is inversely proportional to temperature. Now, what will be the delta H of dissolution then? So delta H of dissolution will be what? Solubility is inversely proportional, na? देखिए, solubility कहाँ था? Inversely proportional. It was in exothermics, right? If I increase the temperature, it is leading to decrease in solubility. So delta H of dissolution for the case of gas inside liquid will be delta H of dissolution will be, it will be less than 0, and it means exothermic. Okay, so the process is going to be exothermic. You can also write increase in temperature leads to decrease in solubility. Please write this down. All of you understood this point? Yes or no? Please tell me about the effect of temperature.
Yes.
Yes, sir.
yes.
Yes, sir.
Okay. The next factor is important. Effect of pressure. Pressure. No. For pressure, what I want you to do is compare two different situations. So let me make some situations here. and I've made an inlet somewhere here, and from this inlet I'm introducing gas. Let us suppose I have added or introduced 5 mole of gas. Okay, so obviously some gas particles will be here also. And some of it will be inside the solution. So there is a similar case. There's a similar case here also. The only difference is that in the second case, I have added a movable piston and I have also applied some weight here. All of these are weights. Okay, so you have situation A and you have situation B. Everything is same, just that here I have not added any weights, but here I have added a movable piston and I have added some weights here. अब ये बताइए, both of these are sealed. Okay, by the way, both of these are sealed. No gas will escape from any of these two systems. अब ये बताइए, where will the solubility be more? कहाँ पे solubility ज़्यादा होगी, A में या B में? What do you guys think? Raise your hand if you think the solubility will be more in the A situation. The solubility will be more in the A situation. जिनको भी लगता है, please raise your hand. Oh, no one. अच्छा, equal वाले, raise your hand. Those who think it will be equal. Zafar thinks both are equal. Okay. Fatima also thinks both will be equal. Zafar thinks A will be more. B वाले hand raise करें. Those who think it will be B. जहाँ पे solubility ज़्यादा होगी. Okay, okay. Okay. So many of you are thinking in terms of B. चलिए. So let us take a look in both the cases. Let us take a look in both the cases. Answer me, okay? Answer me. In the second case where I have added weights, so this piston, it will be moving down and it will be applying a pressure, yes or no?
Yes, sir.
Yes.
It will be applying a pressure, yes or no, guys? Tell me.
Yes, sir.
Yes,
Okay.
sir.
Similarly, the same pressure, it will also affect the gas particles which are inside the solution. Sorry, so not inside the solution, which are inside the container. So all of these gas particles, they will experiencing a force, a downward force due to the pressure. Yes or no? Please tell me.
Yes, sir.
Yes.
And rather than now, when they are facing a force of attraction in a particular direction, they will be moving in that direction only, है ना? But gas, they are randomly moving in the A. In the A case, what is happening? They are moving randomly, right? अब ये बताइए, इन दोनों में से किस केस में, where do you have the chances of solubility more, A or B?
Should be.
All if you agree, yes or no, please tell me. B में there will be more solubility because there is a pressure in the downward direction and the gases will be biased to move towards that direction. Yes, Adriel? Is that
Yes,
clear?
sir,
Yes or no,
also.
please tell me.
Yes, sir.
Adriel, बताइए. Adriel, can you please tell me what did you say? I could not hear you.
I said yes, sir.
Yes, sir. तो थोड़ा जोर से बोलिए. समझ नहीं दे रहा. ठीक है. Okay, so B will be, in the case B, will be having more solubility. Now we have proved one thing, that solubility is directly proportional to pressure. It is directly proportional to pressure. And we can also infer, and as we will infer in the latest cases, that if I am seeing a gas solution, which is having a high concentration here, that means there will be a high pressure here also, है ना? Both of these things, I can infer that. If I am seeing a high solubility, that means high concentration means what? High amount of solute in solvent. High amount of solute in a given solute in a given amount of solvent. That means it is concentration only. The concentration is high, that means the pressure will also be high. ठीक है, उसको बाद में देखेंगे. First of all, oops, sorry. You don't have to write or draw this diagram. ठीक है? Just need to write the point that solubility is greater. Is directly proportional to pressure. And next, the statement that you have to write is the solubility of a gas. अरे आप लोग ऐसे हम लिखने चालू करते. If you want to draw, take a screenshot ना and leave some space. खुद से draw कर सकते हैं इसको, है ना? I have not drawn anything. Biology में जरूरत होती है ऐसे drawings में teachers की, because it has got labels, right? यहाँ पे तो उतना कुछ label भी नहीं है. Okay. Solubility of a gas at a given temperature is directly proportional to the pressure at which it was added, है ना? To the pressure at which it was added. Is there anyone who is still writing?
Sir, I'm still
Is-
writing.
Okay. Anyone else other than Umar? No. ठीक है. Umar, just let me know when you are done, okay?
Sure, sir.
Wait a second. Huh? Chaliye, write this fast, Umar.
Done.
Okay, done. So now the next diagram is important. उसको बनाइएगा आप लोग सब कुछ, ठीक है? So here we have a container. In this container we have some liquid. Let us say that it is water. Let us say this is water. And you have added some gas particles here. Okay. Now tell me all of you, please tell me. If we just have water, let us say you have just a container like this, and यहाँ पे सिर्फ और सिर्फ पानी है, क्या है? You just have water here. So some amount of water will be escaping out to the surrounding, right? Due to evaporation. Correct? Hai? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Right? Okay. अब ये बताइए, when you have is someone saying something? No. Okay. So if you have water that is liquid and it is escaping out in the surrounding, then obviously some amount of this solute, it will be also escaping in the surrounding. Yes or no? Correct? Hai? All of you understood this? Yes or no? Please tell me.
Yes, sir.
है ना?
Sir,
They are
so
escaping.
how?
How is water escaping out? Tell me.
Okay, I got it.
So see, there are a few things of thoda सा सोचिए ना, then you will get it. Like, okay, fine, the escaping tendency. Let us talk about escaping tendency, है ना, which can escape more easily. Liquid or gas? Obviously, gas can escape more easily, है ना. So if at normal temperature, if a liquid is escaping, that means water is escaping out of its own surrounding, जहाँ पे you have only water and it is converting itself into vapor, then obviously, if you have a solute which is gas, it will also escape and it will be here. So you'll always see some amount of solute which is not dissolved. And now this thing will also happen that some of the solute particles, it will be getting inside the system, because again, because they're moving randomly, they will just penetrate inside the solution. Okay, so we have here two kinds. Here we have solute. These are in aqueous phase. Assuming that aqueous phase, assuming what we are assuming here, we are assuming that okay. So aqueous phase, and this is in vapor phase. Okay, this will be in vapor phase. Okay, now if I say that the concentration of the solute particles is high in the aqueous phase, and is high in aqueous phase, that means more and more solute particles will be escaping out in the vapor phase, and more and more solute particles will be escaping out in the vapor phase. And if we have more, please listen very carefully, don't write anything, listen very carefully, that if we have more vapor, that means I am having more gas, and if there is more gas, then the pressure that is will be applied by the gas will also be more. Yes or no, please tell me. The pressure that will be applied on the container's wall, it will be more due to this gases. Yes or no?
Yes, sir.
Yes, sir.
So we can say the pressure will also be high. We can get a relationship. Yeah, the relationship will be pressure is directly proportional to concentration of solute. And like after much trial and error, because concentration terms can be many, and mass percentage se leke mole fraction tak you have concentration terms only. After trial and error, it was found that the pressure, it is perfectly aligning with the mole fraction of solute. Type B is what? Mole fraction of solute. And after that, you can remove the proportionality sign and write the pressure is equal to K, some constant. And since this whole thing was derived by Henry, this constant is named after him, KH, Henry's constant, multiplied by chi B. So here you have KH, this is the Henry's constant. Can you please write this down? Let me know when you're done. What did you not understand, Umar? Concentration is high, yes, Maya. This is the assumption that I am taking. Yes or no? Tell me, Umar. Turn the mic on.
Yes.
The escaping tendencies are if the concentration is more and more solute particles, they will escape out. Correct?
Yes, sir.
If more and more solute particles will be escaping, that means vapor phase may also you will have more solute particles, right?
Yes, sir.
And vapor phase is a gas, correct?
Yes.
If you have more number of gas particles and gas applies pressure, right? ये पता है आपको?
Yes, sir.
So if you have more gas particles, the pressure will also be high.
Okay, understood.
Got it? And the reason mole fraction is used, because after trial and error, it was found that mole fraction is perfectly aligning with the pressure, and it is having the like the proportionality is much suited in mole fraction rather than any other concentration term. That is why mole fraction is used after experimentation. Write this down, all of you, please. Then all of you, yes or no, please tell me.
No, sir, I'm writing.
Okay. Is there anyone who is still writing? Okay. Mohammed Umar, let me know when you're done, okay? Done, Umar?
Sir, about to be completed.
चलिए लिखिए बाकी सब
Done, sir.
Henry's. Okay, Henry's law. What is Henry's law? Okay, please write this with me. Please write this with me, all of you. Partial pressure of a gas. Partial pressure of a gas in the vapor phase is directly proportional to the mole fraction of gas in solution. Of gas in solution. Okay. Can again write this formula. P is equal to KH into chi V. So the P here is telling me about partial pressure of gas in vapor phase. KH is Henry's constant. This is mole fraction of solute in solution. Okay. Now, can you move on? Yes or no? Please tell me. लिख लिया ना सबने? Okay. Now, let us talk about the Henry's constant KH. Okay, Henry's constant KH. So first thing that we'll discuss about Henry's constant is unit of KH. So we know from the formula that P is equal to KH into chi V. We can write KH is equal to pressure upon chi b. So who will tell me what is the unit for chi b? Mole fraction का unit क्या होता है? What is the unit for mole fraction, guys?
No units, sir.
No unit. Correct, Alida. It is unitless. है ना? If it is unitless, then kh will have the units of what? Pressure. So unit of kh will be the same as the unit of pressure. So unit of kh will be, it can be bar, no, or it can be ATM, or it can be torr, or it can be mm of Hg. No, so all of these will be units of kh because mole fraction does not have any unit. Now next thing is, will the kh of all the gas be same or they will be different? So kh will be different for each and every gas. That means kh is a function of kh is a function of gas. It means that if I change the gas, the case will be changed. The kh will be changed. That is, different gases will have different values of kh, different values of kh. Third point. Now please listen carefully, don't write anything now, please listen. If I have kh and you know that it is equal to what? Pressure upon mole fraction. So I can imply that if I take pressure as constant, I can imply that kh, it is inversely proportional to chi b. Yes or no? Clear? Yes or no, guys? Tell me. kh will be inversely proportional to chi b. Chi b is what it is? Concentration, it is what? Solubility. Na? The amount of solute in solvent, solubility. It is solubility. So we can see that solubility is inversely proportional to the kh. Solubility is inversely proportional to kh. It means higher the value of kh, lower will be solubility. Solubility of what? Solubility of gas. Clear ye point? Third point. Is the third point clear with everyone? Yes or no? Please tell me.
So how? Okay. Oh no, I got it.
वो रीजन आ रहा है ना. टेम्परेचर तो अभी बात नहीं किया हम लोगों ने उमर. We are going to talk about temperature now. But हाँ, you can say that previously we have talked about temperature यहाँ पे initially. So solubility decreases with temperature, no? That is why. Solubility decreases with increase in temperature. Okay, that is the reason for point 1. Unit है unit. आपने लिखा नहीं है मोहम्मद उमर. चलिए लिखिए, जल्दी लिखिए आप लोग.
Sir, can you repeat the third point? I got disconnected.
अच्छा. So I am saying kh is equal to pressure upon chi b. ये समझ में आ रहा है, right? Yes or no?
Sorry, sir.
kh is equal to pressure upon chi b. I think if I rearrange this equation, then I will get this now.
Yes, sir.
है ना? ठीक है. Then if I say pressure is constant, है ना? If the pressure is constant, then I can write a proportionality sign. Pressure को constant ले लिया, तो proportionality sign में क्या हो जाएगा? K is inversely proportional to chi b. Correct है? I can't hear you, Adriel. Can't hear you, Adriel. Tell me what happened.
Okay, okay.
Got it? I think आगे समझ में.
Yes, sir.
Okay. Mohammed Umar done?
So I'm writing the last point.
Okay. But write fast ना, everyone has सबका हो गया. Write fast.
Done, sir.
And okay. So we have already seen that if I increase the temperature, then gas in liquid, the solubility decreases. Right? Solubility decreases. Okay. If the solubility is low, KH will be high or low? Tell me, guys. If the solubility is low, KH will be,
It will be high.
because higher value of KH, lower solubility, higher KH. So we can write temperature and KH में जो relationship है. You can see that temperature and KH, they are directly proportional. They are directly proportional or inversely proportional? Tell me.
They're directly proportional.
Directly proportional.
Directly
Right?
proportional.
Very good. So KH is directly proportional to temperature. KH is directly proportional to temperature. Now all of you will write a question. Aquatic animals are more comfortable in cold water than in warm water. Why? So essentially in this question, the question is not asking about the comfortability of aquatic animals in warm or cold water. They are asking about the solubility of O2. They are asking about the solubility of O2. ठीक है? अब ये बताइए, an aquatic animal will be more comfortable if it gets more O2 या less O2? बताइए.
More O2.
More O2. Now, you will get more O2 at high temperature या low temperature? कहाँ मिलेगा आपको more O2? Tell me. Yes, guys.
High temperature.
I've got one answer that was right. बाकी लोग बताएं.
High temperature.
Who is high temperature here? Adil, was that you? Yeah, who's that? Who was that high temperature? अब कोई बोलेगा ही नहीं. Who said high temperature? जिसने भी high temperature कहा है, just go a bit above, like go a bit back. यहाँ पे देखिए ना, solubility is inversely proportional to temperature है ना? So the temperature is higher, O2 will be less available. Yes or no, guys? हाँ या ना? Alida, Fatima, Huzaifa, Casey. Cold water. Am I not audible, guys? Huh? So low temperature
Yes.
mein O2 will be more soluble, and that is why aquatic animals are more comfortable in cold water than in hot water. Is this clear? Yes or no? Is this clear? Yes or no? Please tell me.
Yes, sir.
एसी, हुजैफा, फातिमा,
Yes, sir.
तो बोलिए ना, इतना आप लोग तो बोलते ही नहीं है, बिल्कुल आवाज ही नहीं आती किसी की। एक्वेटिक एनिमल्स हम हल्का लिख देते हैं, ड्यू टू हायर सॉल्युबिलिटी ऑफ O2 in cold water, that is low temperature. Right, the next topic, graph of Henry's law. Graph of Henry's law. So if you want to make any graph, you need to have an equation. Whenever you're plotting something, you need to have an equation. What is the equation? Equation Henry's law का है P is equal to KH into chi B. So it is similar to the equation Y is equal to MX, है ना? So we can plot a graph here. In the y-axis, we will take pressure of the vapor phase. In the x-axis, we will take the mole fraction of solute in the aqueous phase. And the plot, it will graph, it will pass through the origin like this. Okay. And the slope of this line, will give you KH. ठीक है? Draw this graph of Henry's law. Graph of Henry's law. Raise your hand when you are done.
So what is y?
कहाँ पे y?
Y
I'm
is
seeing
equal-
that it is y is equal to mx na. So P is equal to KH into chi B. It is similar to y is equal to mx. फातिमा आप पूछ रही हो जहाँ से,
Me only.
है ना? आपके पास मैथ है, बायो है?
Bio.
फिजिक्स में आपने पढ़ा होगा कभी ना, ग्राफ्स. हैव यू लर्नड अबाउट ग्राफ्स एनीवेयर?
Yes, sir.
तो उसमें है ना, देयर आर डिफरेंट टाइप्स ऑफ इक्वेशन एंड उसके लिए अलग अलग प्लॉट्स होते हैं. y is equal to mx, देन यू हैव y is equal to mx plus c एक होता है. Different equations for gas, right? Sorry, different equations for graphs. कुछ याद है, नहीं याद है?
नहीं.
नहीं याद है, अच्छा ठीक है. So you can, इसका मैं से explain कर देते हैं. देखिए, P is equal to KH into chi B है. फातिमा, keep your mic on. हाँ, अब ये बताइए, जब मोल फ्रैक्शन 0 होगा, यहाँ पे अगर आप 0 पुट करेंगे तो प्रेशर भी क्या हो जाएगा?
0.
0, है ना? अच्छा, सिंप्लिसिटी के लिए हम क्या करते हैं, KH को हम क्या मान ले, 2 मान ले. ठीक है,
Okay.
ओके, फॉर सिंप्लिसिटी से, है ना? कोई तो नंबर होगा ना, इट विल बी अ पॉजिटिव
Yeah.
नंबर ओनली, राइट? पॉजिटिव नंबर होगा. ठीक है, यहाँ हमारा ग्राफ स्टार्ट होगा यहाँ से, चाहे KH कुछ भी हो, 2 हो, 2, 3, 4, 5, 6, 7, 8, any whatever the number KH is, what you will be seeing that the graph is starting from here, because if the mole fraction is 0, there will be 0 pressure. Correct है फातिमा?
Yes, sir.
And अब बताइए, when the mole fraction will be 1, प्रेशर कितना हो जाएगा? 2 हो जाएगा.
Yes.
तो यहाँ पे कहीं तो होगा ना, यहाँ पे आपके पास chi b आपका 1 हो गया, ये प्रेशर यहाँ पे कुछ 2 हो जाएगा. ठीक है, सो आई एम जस्ट प्लॉटिंग इट हियर. अब उसके बाद फिर आगे इसी में प्लॉट हो जाएगा 4, तो हम 2 रखेंगे तो 2 2 4 हो जाएगा. करेक्ट है?
Yes.
है ना, तो 0 then 2 then 4 then 6 then 8 ऐसे ऐसे बढ़ता जाएगा.
हाँ.
You will get a straight line passing through the origin.
Yes, sir.
Okay. Raise your hand when you're done, guys. Okay. सबको समझ में आया, राइट? ग्राफ, yes or no, please tell me. है ना, सबको आया? ओके फाइन. किसी कोई ऐसे नहीं जिनको नहीं आया ना, ठीक है. Then guys, all of you, please tell me yes or no.